Welcome. My name is Dr. Yedav Pandit and I am an associate professor of physics. Today we're covering significant figures, or SFs. The number of significant figures in a result is simply the number of figures known with some degree of reliability. For example, 13.2 has 3 significant figures, while 13.20 has 4 significant figures. Remember that some numbers called exact numbers, like the count of objects or common conversion factors, for example exactly 12 inches in a foot, are known with complete certainty and are considered to have an infinite number of significant figures. Let's dive into the rules for measured quantities, starting with the easy ones. 1. All non-zero digits are significant. For instance, 1.234 grams has 4 significant figures. 2. Zeros between non-zero digits are significant. A measurement of 3.07 ml has 3 significant figures. Now, where do zeros get tricky? Zeros to the left of the first non-zero digit are not significant. They only show the position of the decimal point. So 0.001 degrees C has only 1 significant figure. But zeros to the right of a decimal point are significant. This means 0.200 grams has 3 significant figures. One quick warning: if a number ends in zeros that are not to the right of a decimal point, those zeros are not necessarily significant. For example, 50,600 calories could have 3, 4, or 5 significant figures. To avoid this ambiguity, we use scientific notation. Writing that value as 5.06 multiplied by 10 to the power 4 explicitly shows it has only 3 significant figures. Next, how do we use significant figures in math? The general rule is that the accuracy of your result is limited by the least accurate measurement involved. For addition and subtraction, the result is rounded off to the last common digit occurring furthest to the right in all components. If we add 100 plus 23.643, the result 123.643 is rounded to 124. For multiplication and division, the rule is simpler. The result should have the same number of significant figures as the component with the least number of significant figures. For instance, if we multiply 3.0, 2 significant figures, by 12.60, 4 significant figures, the initial result 37.8000 must be rounded off to 38, 2 significant figures. When rounding, if the digit to be dropped is greater than 5, the last retained digit increases by 1, 12.6 rounds to 13. If the digit is less than 5, the digit stays the same, 12.4 rounds to 12. Finally, for complex long calculations involving mixed operations, remember this critical guideline: carry as many digits as possible through the entire set of calculations and then round the final result appropriately. Rounding intermediate steps, especially in statistics, can seriously compromise accuracy. That's your quick guide to significant figures. Thanks for watching.